Right? According to the language guide, closures are self-contained blocks of functionality that can be passed around and used in your code. If we remember, functions is basically the same thing, right? A couple days ago, we started doing functions. It's the same description. As we use closures more and more, we'll start seeing the differences between closures and functions. As we get deeper into API and networking, we'll really get to understand what closures are doing, how closures are a reference type. When we talk about classes, we'll understand and better understand what's happening here. Today, the objective is to get us up to date and understanding closure syntax. As far as like the intricacies of it, going deeper, as we go further into the units and lectures, we'll get more familiar and understand the slight differences between closures and functions. But closures right now are functions. Everybody with me? Okay. So, the syntax for closures is again very similar to functions. If we scroll down here, this is the closure syntax, right? We have a list of parameters. We have a return type. Different from a function, we have the in keyword. We've seen the in keyword in the for in loop, right? So here it says for parameters with return type in this closure, go ahead and execute whatever statements we want to write here, right? That's the basic syntax of a closure. So as you see in that, if you actually write it down on your notebook or in your computer, right, make sure that you capture what the basic syntax is, because it's, as I said, it's easy to lose track of what the correct syntax of a closure is, right? That's why there's sites like, if you just Google and look for Swift, right, Swift closures, right? There's a site dedicated to just talk about closures here. Well, we want a friendlier one here. So let me quickly scroll down and get the friendlier version of this, right? So here, how do I declare a closure? That could be a site that you bookmark, because you always come back to, oh, how do I do this in a closure, right? So I will slack this out to us as we go through the lecture. Also bookmark this as we go through closures and as we go through your assignment for the week. How do I do this? We're using a closure, right? We'll go through the basic syntax of it, but that site is also useful in trying to remember or bookmark how the syntax looks like, right?
Yeah. If it's great, you can get them on this.
Excellent. Thank you. Cool. So now we know what a closure is as far as the difference between that and a function. We haven't really seen the differences that much, right? So far we've seen the syntax in keyword is not in a function, right? But again, it's as a function. A block of code you have, and you could pass it around. As I said earlier, a closure is a first-class citizen. When you hear that being mentioned by Apple or WWDC videos or wherever you're reading, anytime you see first-class citizen, it means that object or that structure, whatever that is very similar to a variable in our code. I could pass it around, I could call it in a function definition, right? I could declare it, I could get a return value of a closure, right? It's passed around like a regular variable. That's what it means by first-class citizen. Okay, so now let's go ahead and do some actual closure syntax. So here we said a closure is a block, very similar to a function, a block of code that can be called in our program. Similar to a function. In fact, a closure is a type of function. We will see and recognize differences as we journey through this course. Cool? So great. So let's talk about closure syntax or document what it looks like. Yes, sir.
Sorry, are closures a type of function or functions a type of closure?
I would say closures is a type of function. Because at the end of the day, they're all functions. A closure could be called an anonymous function, as in JavaScript. Yeah. It's a function without a name and the funky word. Okay, cool. So we have a basic function, right? Let's go back to what a function looks like. So here we have a function. We have the keyword func. We say add numbers. We say add numbers. We have a parens, right? In that case, does it take arguments or not? It doesn't take arguments, correct? The parameter list is empty. It does not take in any arguments. Does this function return anything? If a function doesn't return anything, we could say it returns void, right? It returns void, nothing. Void is empty. Everybody with me? This function does not take in any parameters. It doesn't return anything for now, right? So I could say it returns void. Let's actually change the name and just call it simple function. Or print greeting is probably better here. Okay, so print greeting, that's the name of the function. A function starts off with the func keyword, followed by the name of the function, followed by the parameter list in that case. In that case, we have nothing. There's no parameters in there. You have your open curly, you have your close curly, right? In here, I could put a print statement. I could say print good morning, iOS 6.3. Right? So far, so good. And here, I could call my function by using the name print greeting. Right? Now I could go ahead and run my playground and expect good morning iOS 6.3 to get printed out, which it does, right? So line 15 is the actual line that executes that function. Everybody with me? So here is the basic syntax of a function. You have the func keyword, you have the name of the function, followed by parens, and the open and close and curly brackets, followed by any statement that you want. Here is statements or code. Right? If we would like to have a parameter in this print greeting, actually, let me stop 1 second. Let me show you what void looks like. You may see once in a while, you come across code that looks like this. Right? I run my code. I get the same output. You could explicitly put void here, but avoid doing that. Everybody? Here, void is nothing. Right? I want to show you that for purposes of showing it to you. But with a function, right, you do not need to say arrow returning nothing. Everybody with me? Okay, so here we omit it because we're not returning a value. There's no return keyword here. We're not returning a value. Yes, Christian?
So, is that like a practical thing?
The less code you write, the better at the end of the day.
Right.
The more code you write, the more bugs you have. In that particular case, it's not Swifty. It doesn't look right. I'm not returning anything. Why am I explicitly saying I'm not returning anything? Right? The function as is right now tells the reader of the function, right? Anybody who passes that intermediate level of Swift, right, come end of unit 1, you should know this function does not return a value by just looking for the return arrow. And also, there's no return here, right? It doesn't return anything. It just prints, right? So there's no reason to go extra and say, hey, I'm returning void.
So return is like
Yeah, if you say add numbers and you add add number one plus number two, you need to return a value. We'll see what implicit returns look like, right? But even implicit return still has the return keyword, the return arrow. Cool? We might see, we will see implicit return today. All right. You may see void in closures, but in functions, avoid having return void. All right. Okay, so here if you want to have an argument, I could start off by saying name and string. We expect name to be a string, right? So name here is an external parameter name. I need to use name when I call print function. It's complaining already. The compiler is like, hey, missing argument parameter name. So here we need to say name, followed by the name. Right? So that name here in that colon is an external. External meaning external to the function, but visible to the person using the function, right? So this here is an external name. If you do not want to have the external name, what do? Oh, somebody said it. Underscore, right? So we put an underscore. We precede the external name with an underscore, right? Now the compiler says, hey, extraneous argument label name. Because now we're saying we do not need the label name. Everybody with me? Do it again. Okay. It depends on how you want the person to use your function. If I want the person to say simply greeting, print greeting Alex, without having the name there, I'm the person writing the function. I'm like, hey, it's cleaner for them to just pass in a string as opposed to having a label name there. It just comes down to preference or code style based on the company, right? So some companies will be like, hey, I don't want the label name in there. There's no context, right? So in that case, you would ignore it by having an underscore. So go ahead, ignore the external name, okay? One second. So if we ignore it, you're saying, Julia. So if we ignore it, it's going to print. Well, I haven't interpolated Alex. So let's go ahead and interpolate Alex, right? So it has name. So good morning, name. Welcome to, okay? So if I go ahead and run that particular code, it will say, good morning, Alex, welcome to iOS 6.3, right? I still have this name here, now is an internal name to the function, right? I have access to it on line 12. It's internal to the function. Here, the user does not see it. It's very similar to the print, right? When I say print, everybody with me? Still with me, right? So if I say print here, right? Printing. Do we see a label? There's no label on this function, right? It simply says print whatever the argument is. In that case, it's a string. Everybody with me? It would be a bit verbose to say print string like that, right? Which one looks cleaner? This one looks cleaner, right? Everybody with me? So it depends on the context that you write in, or the code style, or the company, or different variables there. Everybody with me? But knowing what the differences are is very essential and important. So know the first name is, in that case, if we have two names, the first one is the external, the second is the internal, okay? Underscore is going to ignore it. In that case, in our on line 16, we do not have it, right? But it still uses the internal here. But the person using this does not see the internal name. Cool? All right. Just wanted to review this a little bit between internal and external. So internal parameter names are used in the function body definition, and external parameter name is used by the caller, they will see the external name. Example, print reading name block. Cool? So that's for external here. If you have an external name, they see the external name. Everybody with me? Okay, so Stephanie, not Stephanie, sorry. Tiffany, if you have an underscore, you cannot have a label name here. Vice versa, if you do not have an underscore, you need to have the label name. How is your definition? It's fixed? Okay. All right, cool. Yes, sir.
So external parameter for reading Alex. Which one's the external parameter?
The underscore.
Underscore.
That's why it's not explicitly seen in the caller on line 19. Cool? Any other questions? Please ask the questions. All right? Not wait after lecture and you lost and then it's not good, right? You have questions, ask them now. Yes?
I'm confused with the underscore. So it's ignoring the name, but the name is still.
Because the name is only used inside of the definition of the function. Inside the body here, right? The name being passed is this string. Everybody with me?
Oh, so basically you're saying it doesn't matter what the name, like you're not
Yeah, I just want the string,
Okay.
right? Because that's what our data type says.
But you still have to put name there, or you do
To actually print out what the person passed in.
Okay.
So what the person passes in comes in here, right? I see it as name, and I string interpolated here, right? So it doesn't matter what string I pass in here, I will be able to capture it in the, yeah. Yes, sir.
So the thing about it is, we don't need, in this example for sure, like, we don't need name, we don't intend to interpolate, string interpolate the function.
Either way, you still have access to the parameter name.
You have it, but if you're not going to use it within the function, you don't need to label it.
Well, we're still using it within the function here.
No, right, but if you did, like the first example where you didn't use name,
We could have still used it, even if we did pass it. Like, so let me go back, right? So if we do, yes, Eric, before I go back to the previous code.
I got two questions.
Okay, go ahead.
The first question, so we only use the underscore
So that line 19 doesn't have to write it in.
so it's not necessary.
Exactly.
to go back. And then secondly, because we use the underscore, it doesn't mean we can't use the variable.
Exactly, we still have access to that variable, which is what Christian is asking. Even if I have the label name or I don't have the label name, I still have access to the variable.
how would you call for it?
Let's do it again. So if I say name here, everybody with me? And I take out the underscore here, my code still compiles, right? It still compiles, I still have access to it. I could still go ahead and run my code and have my name.
No, but it's the first time we did that name and underscore,
Uh-huh.
that's still right.
Say that again. The first time we have underscore.
Yeah, like first example that we didn't get underscore. But like the function line 13 said a name has underscore.
Mm-hmm. Put the underscore now.
Yeah.
Okay, go ahead, underscore here. I have to remove this. That's a compiler error. Right? Okay, continue.
The first time though, we didn't have name in there.
The first time we just had a string. We didn't have name. But if you want to have the person's name printed out, you have to string interpolate it. Right? Right? Makes sense, right? If I pass my name, I want to see the name printed out. Cool? We were getting there. We were building on top of it.
You can use underscore only if you have one parameter.
You could do it on many parameters. Yeah. I could.
Don't get confused. Like, how will it know which?
You want to, whatever you pass in, like by commas, you pass in commas, and then it will know.
So it would be like last name, first name.
Exactly. But I don't want to go there right now. Okay? But you could have many. All right. Yes, sir.
I didn't hear what you said you're allowed to do that on multiple.
Luba was saying if we could have multiple arguments like this. So name, age, for example, is a string. And here, let's pass in age of 45. And here, let's ignore this. Oh, sorry. So that's an integer, right? And let's say, good morning, name. Welcome to iOS. Your age is whatever age. Right, so good morning, Alex. Welcome to iOS. Your age is 45. You could also ignore it. The compiler understands by the comma, first argument, second argument, first parameter, second parameter. You with me, Luba? Yeah. No, that's fine. That's good. We gotta ask the questions. Exactly. Not to type in name, not to type in age, right? Any other questions? It's good to review before we go ahead. Yes, sir. Oh yeah. We haven't spoken about default parameters. I'm not going to do it today. I'll do it when I talk about in-outs and default. But we could have a default parameter, very similar to print has a default parameter of terminator, right? So I do not have to put 45 if I have a default 45. If I do that now, I'll start losing people. I don't want to go into default right now, but you can. Cool? By having a default age of some number, like 21, and if I don't put 25 in, it's going to work. That's the only way, if you have a default parameter. Cool? It's in the lesson if you want to double check on it, on day 2 of functions. Yes, sir?
I'm just thinking about, if you make it like a dictionary, for example, of like 3 things, could you call for that variable print treating? Like so that it does like 3 names and 3 at a time?
Yes, you could do dictionaries and call the function and have it print out all the names. You could do more complex work there, right? Yeah, that's good. Yeah, it's good. But yeah, you could have a dictionary called print greeting, give it a dictionary of names. It's just gonna call the names and print it out. Yes. That's all part of like what we've learned for the last 3 weeks. That's why we have bigger labs so that we could put all that knowledge together. Make sense? Yeah.
So just to reiterate what you said, you can have a default value in a parameter.
You guys want me to go there?
Okay.
Okay. All right, we'll go there. So let's do default parameters here. So default parameters, everybody on line 13, correct? A default parameter is very similar to how we use print terminator. Everybody remember that? How we have print terminator? I could say print, right now, do I have a terminator keyword in there on line 19? No, because the default parameter terminator is new line. Remember we said that before, right? If I do not specify a terminator for my print, it defaults to new line. Everybody with me? If I give it a value, it overrides the new line to whatever value I give it. Everybody with me? We could do the same thing here. I could say greeting name. I could give it a default age of 21. I could remove this 45 here, and I could run my code, and it will say, good morning, Alex. Welcome to iOS 6.3. Your age is 21. I'm forever 21. It's awesome, right? So let's see what happened there. What did we do? In our parameter, I included, please do this with me. Please ask questions if you have any questions before I go on and you say you don't know what default parameters are, right? So let's go back from the beginning. I have 45. I run my code. It says, good morning, Alex. Welcome to iOS 6.3. Your age is 45. Everybody with me? Good. If, as Miguel was asking, if I want to ignore the 45, only passing the age, how can we do that? Currently, our function takes in 2 parameters. Do we agree? Or 2 arguments here. Arguments on the call, parameters on the definition. Currently, our function takes in 2 arguments, a string and an integer. So far, so good? If, for some reason, I do not care that the user puts in the actual age, and I'll use some default age for some reason. I could have what's called a default parameter value, right? So let's put default here. Let's put some comments. So default parameter value here, default parameter value, we will set on age is 21. In the case the user or the caller of our function uses, in the case the caller of our function does not provide age argument, we will default to showing 21. Everybody with me? Everybody with me? If you lost, let me know. Yeah. Yes. If the person puts in 45, it will override the 21. Good observation, Chelsea. Any other questions? Don't bother the questions in, please. It doesn't help you, it doesn't help us. Next thing we got to do is set the default. How do we set the default? We set the default after the data type that we're interested in. We set the default after the what? The data type that we're interested in. So here, set default value on the data type that we are interested in. Example, age int equal to 21. Yes, you love optionals. You see that? Now you're referencing optionals already. Very good. All right, cool. So what are we doing after int, right? Everybody? So after int equal, right? 21. So far, so good? Cool. If we run the code as is now, what gets printed? Everybody needs to agree with that. If you have any questions, please, we could go over it again. In my parameter list, I have int equals 21. On 25, the user of my function, the caller, they passed in 45. 45 overrides 21. What this says, if there's no argument passed, go ahead and use 21. But if there is an argument that passed, use that argument. Yes? Nothing to do with the underscore. Absolutely nothing to do with the underscore. This is a separate issue, different question, somebody asked. Right? Based on the syntax here I provided, I said equal 21, I gave it a default value of 21. If I do not pass in 45, use that 21. Right? That's all it says to the compiler. Right? So now if I run the program, what gets printed? 21. Right? So now let me show you one more thing. So if, go ahead and print out a different statement. Right below the print greeting, go ahead and start typing out print greeting. What happens? How many initializers do we have now? Or how many function calls we have now? How many function calls do I have on the screen? We see 2, right? Before we had 1. Now we have 2 options. Option 1, passing only age. Everybody sees that on the computer? Let's go back. Print greeting. The option comes up. Sorry, name. The first one says name, right? Print greeting name. It only accepts name, right, everybody? Sorry about the age. The second one accepts a name and an age.
Why is there not a third one that accepts an age?
You could do a third one if you want. You could have a default on the name, but we haven't done that, right? You could. You should test it out, right? Everybody with that? We saw two, correct? Okay. Yes, you could have a third. You could have a default on the name, right? But that gives us a basic knowledge of how to use default parameters. Everybody with me? That's how the print function works. You have print, you could override terminator. You have print, you don't have to use the terminator. It has a default N already. Yeah. You used it on print, right? It came in handy for us, right? If you want to override terminator, right, that's a perfect use case. That's why sometimes we try to, yes. In the case of print, if we want to go ahead and override the new line, we could say terminator, I want to override you with an emoji or whatever I want to do. Cool? That's why sometimes programming is hard to show things you haven't used yet or you don't know how to use it yet. It gets confusing. Why am I learning this? That's why I've been holding back on certain topics because I'm like, yes, I want to show it to you, it's exciting, but how do I use it? Right? In, out, we haven't used it yet. We'll come to it. Default, we understand why and how we used it now, right? We used it on print, so we understand what it gives us. Everybody with me? We understand external and internal parameters. We use print, double quotes. We don't say print string, colon, double quotes. We say print quotes. We're done. Everybody with me? So we know the reason why we have internal, external, based on what we want to do, right? Yeah.
One thing I'm sure on is underscores in our function.
I could take out all the underscores here for now, but I want you to understand why we have them.
So yeah.
The print statement. Go back to the print statement. When you type out print, what happens? Do you see print string? Right?
Oh, no, okay. Oh.
Right. When you say print here, the person who wrote print, they did not say explicitly we have to say name, like this, and the string we want. Right? It doesn't take in an external parameter name. Right? That's ignored. It's underscored in the documentation. Right? All what we do is say print, argument is a string.
So, when you start writing print read has two different.
Yeah.
That is only for code.
We have the default.
Alright, but my question is like, is it necessary to always put the one that's older than?
Not necessary.
But if you select the first one, won't you still?
Not necessary. It depends on what you want, what context you want. Because as I said, like further into the course, we'll see there's options where you only want to have one argument passed in to whatever function you want. We'll come to examples like that. Where you do not want all the arguments, you want one argument.
If you don't want to print the default,
If you do not want it to print the default.
like, you just put like, you type it out, and you don't want to be like giving people nothing or like no.
I mean, in that case, you don't have an age, right? You don't have an age, you can make it optional. But if you did not write the function, you don't have a choice. If you wrote the function, you could put in nil, for example, and then it's just not going to print the age. You with me? That gets deeper into how the person who wrote the function, what they were thinking, right? In that case, if you're the person writing it, and the person does not put in an age, just don't show the age. If I did not pass the age in. Cool? Chelsea, we good? Okay. Yeah. Return in this function. Why is there no return in this function? Luba is asking. Not all functions return values, right? Okay, let's come back. It's good that we actually reviewed a little bit here. Do all functions return a value? Does print return a value? It just prints, right? Our function here, it says print greeting. It just prints the greeting. It doesn't return anything. If we wanted to return something, we could make it return. If it's mathematics or if it's some calculation, if we say we pass in some array of integers, we want to get the sum, you have to return the sum. It depends on what you're doing. A function could return a value, it could not return a value, based on the logic. I'm just printing something. Exactly. Very good. Okay, cool. All right, so that's a brief review of functions here. before we go into closures. All right, I will grab back my closure syntax and I will say, instead of closure syntax, just rename this to function review. Any other function questions you guys have before we continue? Yes? Okay, all right, that's fine. So we'll do one more thing with Terminator here. So Lily was asking about Terminator review. So here I have Good Friday morning. Right. Excellent. I have Good Friday morning. Great. I print it out. It says Good morning Friday. I mean Good Friday morning, right, everybody? Okay. I want to go ahead and change the Terminator. The Terminator is the last character in that print statement. I want to change it from the default. What's the default? New line. I want to change it from default new line. So the default, we saw escape characters, right? So the default looks like this, right? It's a new line character, right? So that's the default. It's a new line character. Default new line character for Terminator, right? If I want to go ahead and override that default, I have a comma after my string. I say Terminator, right? And here I could put whatever I want, whatever character I want, right? In that case, I could simply put right? I could put in whatever character I want. I have a Unicode emoji here. I put that in. I run my code again. And now it says, Good Friday morning. Woohoo, right? It's great. It's Friday. Right? So that's a Terminator, Lydia. So now that Terminator here was a default value on print. Very similar to what we had before. With this particular print greeting, we had a default age, right? We didn't use it. But here, we have a default Terminator argument. We went ahead, we overrode it on print statement. And we said, instead of having new line, have an emoji. Does that help you? No, there's no other new line. So if we, good question, Julia. So here I could just say print, because there's no other new line. So I have to break it by just saying print new line. What I just printed out on line 29 breaks it. Because if I have any other print statement, it will be on the same line. Okay? Lilia, does that answer your question about Terminator? Any other questions about Terminator? You understand what's happening there, right? Like I had new line, it only broke the line. Now I'm removing new line, and I'm changing it with an emoji. Everybody good? Zara? Zara, questions? Yeah. What's that? What's the point of using Terminator? It's up to you. Okay, we're writing some, remember we had some print statement before, and we want to have everything printed on the same line. Right? We went to some for loop. We're like, okay, it's printing everything on a different line. So we said, don't print on a new line, have a space. Right? Example again, more review. So here, if I have an array, not an array, let's just create some for loop. So for index in 0 to 4, for example, here. And I want to say print this, right? You could go ahead and grab that code, everybody. Grab that code here and put it in my for loop. So far, so good? If I do not have the Terminator, what happens? How is the print statement happening? If I do not have the Terminator, it stacks it up, right? Let's run it. Good Friday morning, they're stacked up, right? Because there's a new line here. When it gets to the G, it hits return. Every time it gets to that last character in the string, it hits return, goes to the new line, hits return, goes to the new line, hits return, goes to the new line. Do we see that? Do we see that? So, if you want everything printed on the same line, right? Or whatever you want to do, you go ahead and you use the Terminator on it. In that case, we just want to have an emoji, for example, between our statements. So if I run the code again, what's going to happen this time? Right? I have the emoji interlaced between the statements on the same line. There's no new line there. Everybody with me? Okay. Part of it, we have all the tools, right? We have to get out of just doing projects sometimes and experiment. What if I do this? What if I break this? What if I do that? Playgrounds, open a new playgrounds. Call it testing functions. Create some function for your own self, right? You're into guitars. Create some function with different types of guitars. Whatever, right? That's how we really start enjoying programming. Making the code our own code. I have an array of guitars. Maybe I have a dictionary of guitars with the guitar vendor. Before you know it, you're creating an app, right? If we don't experiment with things that we learn, it's going to be hard. It's going to be hard for that muscle memory to really start working for us. Yes, Chelsea. It's expecting a string, a character. It's expecting a character. Yeah. It's expecting a character. Because that argument data type is character. You see what I'm saying? Yeah. Good. That's exactly what I'm saying. Try and see. Hey, does that work? No, it doesn't. And then you answer questions. All right, cool. So let us, any other questions for functions? We know how to define them. We know they take multiple parameters or no parameters. We know they could return a value or not return a value, right? We know that. Everybody with me? So that's like the basic knowledge of functions there. It takes input. It gives us output. All right, let's go to closure syntax. All right, so we'll start here with a multi-line comment. So a multi-line comment starts with 1 forward slash. A multi-line comment starts with 1 forward slash, followed by an asterisk, and you press return. It gives you the closing comment, right? And here we have our closure syntax. So we have open curly bracket. We have parameters. We have the return arrow. We have some return type. We have the keyword in, as we saw before. You have a closing curly. In between the curlies, you write your code. Okay? So here, that's the basic syntax of a closure. Right? You have a list of parameters. You have the return arrow, followed by the return type, in keyword, and the code that you want to write. Great. So let's see a simple example of a closure. So here I will define a variable. We said closures could be defined and placed in a variable. They could be passed in functions. They could be returned from functions. Right, so closures can be passed as function parameters, can be assigned into a variable, can be returned from a function. Okay. So here we'll declare a simple function, a simple closure. We'll call it greeting. So far, so good. We have our open curly, press return. Right? Already we have a closure, by the way, believe it or not. If you option click on greeting, what do you see? Just who was it? What? Right. So we have empty parenthesis returning an empty parenthesis, right? That is a closure. It's very valid. It's a valid closure. As a matter of fact, yeah. So that's a valid closure. The empty parens here is void, right? So void, it doesn't take any parameters. It does not return anything. Everybody with me? That syntax, as basic as it is, it's a closure, right? It doesn't tell us string returns a string. It doesn't tell us anything like that. It doesn't tell us double returns a double. It shows us parens, returns parens. In those parens, there's no data type. That implies it does not take in any arguments. It does not return anything. So it's void. Yes, sir? Void is it doesn't return a value. Nil is it returns, well, in the context of nil, nil is there's nothing exists. There's a slight difference there, right? Nil is you can't use it. Very similar. You could say they're the same, right? But there's differences there, right? Okay, cool. So that is our basic, simplest closure we could write. Let's go back to the code. In the closure, remember, if we go back to, let me scroll down here. If we go back to our definition, it says parameters, right? That part we did. We have parens. Everybody agree? Right? If you look at the option, if you option click again, we have parens here. We agree? And we have a return arrow. Do we not? Don't we not? Right? So, it's the same that we have here. We just do not explicitly see it in the code we wrote. We have the params, we have the return arrow, and the return type is void. So here, that's definitely valid. It's a closure. In our closure, we said we could write any code we want. So let's go ahead and write some code in there. So in between the open and closing curly, we could say print welcome to closures. All right. So here we'll say reading is a closure. Does not have parameters. Does not return. That one doesn't have any parameters. There's nothing. It's void. Nothing came in. We'll see what we mean by nothing came in. Think about it like print. In print, well, if you do not pass in any arguments, you don't pass in any. Let's see what we're talking about. So now I have my closure. It's defined. It's called greeting, right? This here is the closure. I assigned it to the variable greeting. Everybody with me? Important difference. This is the closure here. Open trailing, close trailing is my closure. I assigned it to greeting. The same way we have let name equal to some string, we could say let greeting equal to some closure. This is a closure here. I assign it to greeting. So later in my code, I could use greeting to do whatever I want. Yes, sir?
So if principal closures wasn't in there, that would return void?
Yes. Well, this one returns void too. Remember, it doesn't return a value. Even if I have the print statement, remember, I'm not returning anything. I'm just printing to the console.
So if it doesn't return a value, it would return
Void, yes. Good question. Good observation. So if it doesn't return a value, as Greg is saying, returns void. Right? Returns void, nothing. Right? Void means nothing. There's nothing there. Empty. How do we go ahead and call that closure? Well, very similar to a function. We could simply say greeting. Greeting parents, like that. Call it, welcome to closures gets printed. Right? Remember, it does not take in any arguments. Everybody with me? Eric, we good? Chelsea? So here we have a closure, does not take in any parameters, doesn't return anything. It simply prints welcome to closures. We execute it on line 56. It gets executed. It comes across line 53 and it just prints it. Right? Same as we have a function that doesn't take in anything, doesn't return anything. This is the same case here. Oh, I'm sorry? Oh, so I think you observed this, right? So you did not explicitly call it? Okay. Got it, got it. Okay, cool. So great, great, great. I'll keep this here. So this is a example closure. All right, let's go to a different use case. Closure that takes parameters and returns a value. Okay, so here we'll create a variable, we'll call it square, a constant, we'll call it square. We'll also see how you could type annotate. In that case, we won't type annotate, actually. We'll do the longer way first to see the differences. So here we start out with the name of this particular closure, or the variable name, constant name. We'll have our open curly bracket. We'll press return. We'll start off with the parameter list, followed by an arrow indicating return. I'm sorry? And here you need to explicitly put in the in keyword. If we go back to the closure syntax, that's where closure is, right? You say, like, I got this, I understand it. But the one thing you forget, it might be frustrating. So that's why you want to go back, either look at the darn closures documentation, or go back to your notes and look at the basic syntax of a closure. A closure takes in parameters, return arrow, return type. Don't forget the keyword in here, right? The simple thing you forget the in, you'll get some syntax errors, right? Expected member name of constructor, call. Yes? The return type above. What line am I going to? 41. Yes. Actually, no, it's not. No. In that case, no. Yeah. All right. So let's continue on here. So we have in, don't forget the in keyword. So we have a closure, it's square. It takes in an integer. Takes in an integer. We'll give it a name, num. And it returns an integer. So I think you were talking about this, right? Sorry. Here? This guy? Yeah. All right, put it in parens, sorry. Okay, so we have a closure. We assigned it to a constant called square. We have our closure syntax. We have our open curly, followed by our close curly. Here is the parameter list. We have one parameter so far. It's a type integer. We have the return keyword. or the return arrow, sorry. We have the return type, which is an integer. So far, so good. And now we could simply say return num times num. This is familiar, right? Return num times num. So far, so good from a function, right? Right, so far, so good. We haven't totally, right? We're not off the tangent there yet. Any questions so far? Just syntax, right? So closure, we have our open curly bracket followed by the parameter list. And here, yes, we could have more parameters followed by commas. Everybody with me? Followed by the arrow, shows the return type. Followed by my return type here, integer. The in keyword is mandatory here, same as for something in collection. And my return says it's square, so it should square the thing, right? Some number times itself. Return that. Whatever number comes in, I get back the square. Everybody with me? So now let's go ahead and use our square. So square. Do you observe square? As you type in square, do you observe what data type it is? Earlier we had empty parents, return empty parents. Everybody with me? Right now, what do we have? We have int, right? Int comes in, int goes out. Right? That's a closure here. Right? Takes in an integer parameter, returns an integer output. Okay, cool. So now type in square. What's the type it expects? Okay, so here we just put in 10. We run our playground. We expect 100. Right? Everybody with me? Yes, sir.
Are there any instances where, like, let's say, thinable
You can. You can. I mean, we could do one of those once we get the gist of what's happening, but you can. Like I take a 10 and maybe I return 10 as the word 10. Yeah, you could do that. Yeah. Definitely. You could take an int and return a bool. You could do anything. I could return optional. Right? We like optionals. What's that? Oh, you want to print it? Oh, just print it, embed it in the print statement. So print here the result of the thing, because it returns a value, right? Cool? So Stephanie was asking, do you want to print it up to the console? So since it's returning a value, we could just embed it in a print statement. Everybody agree with me? Okay. So here we have the square of 10 is 100. So far, so good. Great. But this could get better. This could get better. I'm laughing. I don't know why. Generic, you said? How much better, right? Depends. It's very relative. You could print up there. That's fine. You could have a print statement here. Yeah, it would print before the value. Yeah, you could do anything there. Remember statements, any statement you want. Cool? But if you return in, you have to return something. And you have to return the valid data type. I can't return bool. I have to return an integer. Everybody with me? You could do anything else before that. You could print whatever. Fabulous day, marvelous day, awesome weather. Cool? Great. All right, so let's see. How can we get better here? So here we have closure syntax. We have return keyword. We have argument name num. This could get better. Again, that might be relative based on where we are. Right? I might see it as getting better. All right, so let's square shorthand syntax. Okay, we agreed we have a closure takes in an integer, returns an integer. So far, so good. So we could type annotate. We love type annotation. So here, we could type annotate. I have an integer. I'm returning an integer. I could say that to the compiler. Right? And now I could go ahead and define what my closure looks like. I could say return inside. I could say that. Right? Or I could also do this. Crazy. I could put everything on one line like that. That's insane, right?
Oh, wait.
I'm waiting for it.
But why is it zero because that's the position of where the integer will be?
That's one of them. It's 0 because it's only one argument. It's the first argument. If I have 2 arguments, it's 0, then 1. If I have 3 arguments, it's $0, $1, $2. Here I have 1 argument. I could refer to it using shorthand closure syntax, $0. $0 times $0 is the same value times itself. This is pretty much as simple as the simplest you could get, really. I mean, I could show something crazier, but I'll explain. Right? No, but we have to understand that one first. So let's go back, right? Let's go back. Let's take this out. We agreed with the type annotation, right? We agreed the syntax integer parens arrow integer is a closure. We agreed with that, right? Right. Oh, yeah, the other way, exactly. Shorter way. Right? This way we have, go ahead, go back and option click on square. It's the same type annotation we're doing here, correct? Everybody? If we option click, the data type is the same data type as the closure annotation, correct? Correct. Great. So let's come back to it. So here we type annotating. You have to type annotate in order for Swift to know you're dealing with a closure. That's the only way we could use the $0. Because Swift knows what to expect. We type annotated the closure, right? It knows to expect 1 argument. Excellent. And it knows it could multiply integer with integer. That's why we could say $0 times $0. Yes, sir.
So the dollar sign could represent integer, string.
Whatever argument that is. That first argument, if we have 2 arguments, which we might see today, the second argument will be $1. Yes, sir.
Can you put functions where you put integers?
Can you put functions where you put integers?
Like, see also integer and return integer.
Mm-hmm.
You can put functions.
You could put functions inside the closure, but here you have a basic closure syntax. The closure itself expects an integer, right, as a parameter, and its return type is integer. Cool? You could have functions having a closure as a parameter. I might show that today.
You can put the functions without the parameter.
In that case, no.
In that case.
No. You could have a custom type in there. It's expecting a type.
Okay.
So it could be a custom type, person, employee. Cool? Yes, sir.
I just want to reiterate that to you, so that means
Yeah.
So the dollar sign, right, as if we were doing an array, we close the array and not do or bracket.
So the array will be bracket 0 for the first element. So the $0 is the argument shorthand for closure. All right? So we could write that here. Well, when we finish doing it, we'll write it. Because we did it once to show what's happening. All right, everybody good? Can we continue? Oh, sorry, Stephanie. Yes, we want to show simple first. You could have multiple parameters. I could have 2 parameters coming in. I could have 1 value going out. I could have 3 parameters, 4, 5, 6, 7, whatever amount of parameters you want.
But
You could have multiple followed by a comma.
Coming out.
Yeah. It depends on what you want. I could have a tuple coming out. For now, we've only been returning one value. That's what I'm saying. Let's keep it simple. Understand the basics. I know you guys driving me there. When I go there, you're like, oh my God. It's good. Curiosity. What's curiosity in the cat? What happened there? No, the dollar sign only, dollar sign here, everybody, dollar sign here only works in closures. Dollar sign zero. That's why it's called shorthand closure argument or shorthand argument syntax in the closure. All right, are we good? Can we continue? Are we comfortable with the annotation here? Are we comfortable with the equal sign here? Yes? Yes, I'm assigning the closure to this variable. Okay? And the closure starts off with an open curly. Do we agree? Do we agree? But my compiler expects arguments already. It's like, hey, dude, I expect one argument. That is what it's saying here. Look at what the error is saying. Contextual type for closure argument list expects one argument which cannot be implicitly ignored. You have to provide that argument. You have to work with it. You never said void to me. Earlier we said void, but here we didn't say void anything. Everybody agree? Here we have values. We have to use them. So, as we did before, this is the same problem with doing the shorthand way. The first time we came in here, we explicitly said everything. We said explicitly you have an integer. Everybody with me? Explicitly I use the arrow. Explicitly this is my return type. Explicitly I have the keyword in. Explicitly I have return keyword. And the operation, number times number. Swift is a super intelligent compiler. Swift starts to infer. It infers if you have the $0 times $0, I'm getting an integer in. The return type is also implicitly done. You multiply two things together. That's all you have here. I know I need to return this value. So the compiler does the work for us here. Right? Yes. Exactly. Because integer times integer is integer, correct? Everybody? You're done with that particular problem. It's done. It sees this. It just returns that value. You do not have to explicitly say return here. Right? So, yeah. No, go ahead. No, go ahead. It will work for 2 types, 3 types, as long as you're returning the same type it expects. Right? You have the 3 types coming in. You have some type going out. If you have a type going out, it doesn't care about what you do inside, as far as like the logic of it. You have 2 integers. We might come to an example. You do something to 2 integers. It returns an integer. It doesn't care if you multiply them, divide them. Right? That's how map works. We'll come to map. In that particular question here, it infers the input is an integer because you're working with integers. You said $0. And the output, it infers because you multiply 2 ints together. Because we type annotated. If we do not type annotate and we go ahead and do $0, it will compile fail for us. Ambiguous. I don't understand what you're trying to do. You have to give it some information to work with. I need other people to ask questions, by the way. Not all of us, right? Like, we have to ask questions, especially on a topic like this. After work.
At some point, maybe not right now, but can you directly tell us the difference between closure and function? They look the same.
They look the same for now. Think of them as the same. Okay? Because really and truly, there's the differences that is there, you'll see later in the course. Okay? For now, no, they're the same, basically. Okay? All right. Cool. And for the differences you saw already in syntax, right? The in keyword, that's a difference. right? Not using the name parameter. You saw that. We just called greeting with the string. And there's all the differences coming up. Why we have escape closures and like more complex closures, but we're not getting there yet. Yes, sir.
In the shorthand, would it be safe to say that the dollar sign calls for the parameter with the digit following it, also like the expected parameter?
Yes, I would say that. It expects, in that case, it expects one parameter, so we only have 0, right? If we passed in 2 parameters, we could have said 0 times 1. I mean, $0 times $1. Cool?
So we can only use shorthand syntax after we type anything, right?
Yes, in that case. Yes. All right, cool. So let's keep going. So we have our closure syntax beginning. We have our open curly, our close curly. And since our operation is so short, we'll say again, $0 is the first argument, the only argument. Everybody with me? This is shorthand syntax for closures. And what are we doing? We're squaring, right? Everybody with me? Same as we did on 61. We're just multiplying num times num. Everybody with me? Right? So here, already this is valid, by the way. You see? One number, it doesn't really care what you do with that number. Everybody sees that. So you could return the same value. Right? But here we want to square it, so we want to multiply it again by itself. Cool? $0 is the first argument. Let's put some notes here. So using refactoring means to rewrite the code, basically. So here we're rewriting the code that we wrote above, right? Our square on line 60, we refactored it to use shorthand. So refactoring square closure above to make use of shorthand closure syntax and argument names. And we'll say $0 is the first parameter argument. Here we only have one parameter. If you have, example, 2 parameters, it would be $0 followed by $1, and so on. Cool? So here we call that square. That's great. I will go ahead and test out the square. Make sure what we see is actually real. So square shorthand syntax. Pass in some number. And go ahead and run it. Right? We should get back 625. Everybody? Right? So we could actually assign it to a value here, or just print out the value. Let's just print out, so we're not creating too many variables here. So print out, let's see it in the console, 625, square of 25, right? So basically what we did is multiply 25 times 25 equal to 625. Right? We see where that's more powerful than a function, by the way, right? As you get deeper into programming, you'll start hearing about what's known as functional programming, which we do not teach here. As far as functional programming goes, we show you built-in functional closures and high order functions. But functional programming is a concept by itself, where you only take in functions and functions within functions, right? So here already, this is so much more functional than writing some function, right? I could have a function, call it, square, pass in a variable, write some logic, return the thing. But here, all what we did is have a closure. It infers the type, it returns the type, and we're done with our closure syntax, right? So we could actually use what we just saw to create. Go ahead and practice. Create, add, subtract, multiply, and divide using shorthand closure and argument names. Cool? So we know what we're doing, right? Basically, we're doing what we did on 68. But instead of squaring it, we need to divide, add, multiply, subtract. Cool? So create some constant, give it a name, type annotated, assign it a closure, and print out the result of it. What's that? Ah, getting you warmed up there, yes. So we're creating 4 closures, right? Yes? Very similar to 68. And print out the result. Say that again. Um, Actually, good question. Aha. There's a simple twist there. It's not exactly as 68, right? So expect 2 values, right? Expect 2 values and 1 value out. Okay? Good clarification question. So practice, create, add, subtract, multiply, and divide using shorthand coding. Okay. It's a little ambiguous. But yeah, 2 parameters coming in, 1 coming out. Everybody with me? Everybody with me? That was Stephanie's question before. Can we take in more parameters? Yes, we can. Yes. In that case, we don't need to use in. We did not use in here. Above, yes, in. If you're doing it the long way, yes, in. In is required. If you're doing it the long way.